This video is for Math 112, and this is on section 3.1, trigonometric identities. So, let's see here. Anytime you're working with trigonometric functions like sine, cosine, and tangent, you run into these issues that are sometimes confusing, but sometimes can be very helpful, which are trigonometric identities, in that you can change the appearance of what you're working with to, in many cases, simplify it. Okay? That's typically the goal of a trigonometric identity, is either to simplify something or to put it into a form that will allow you to solve it simply. So, let's see here. So let's start out with the very basic ideas. If we're talking about sine theta, right, that's the opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. And tangent of theta is the opposite over the adjacent. Now, just with this information, we can develop a trigonometric identity because sine over cosine is the opposite over the hypotenuse over the adjacent over the hypotenuse. And this is in the textbook, I go over this, times the reciprocal here equals opposite over adjacent, and that's the tangent. So, that's one identity right there, which is that sine theta over cosine theta is equal to tangent of theta. Okay. So we won't be really using these expressions in the problems, but it's good to remind ourselves of where the sine, cosine, and tangent come from. Then we have what are called reciprocal identities. Let's see, I'll write this in a different color. Reciprocal identities. And these are really just definitions, which is that the cosecant is the reciprocal of the sine function. The secant is the reciprocal of the cosine function. And the cotangent is the reciprocal of the tangent. And so as a result, we can add up here that cosine over sine is equal to cotangent. Okay. So there's some basic information about the identities. Again, these are just definitions. Okay. Now you may ask, why do we care about the reciprocal of the sine? Why don't we just call it the reciprocal of the sine or something like that? The best answer I can give you is that in a body of knowledge like trigonometry, which developed over I don't know, 1,000 or so years, maybe more, all over the world, people used what they needed, you know, and so as these things started getting collected together into a coherent body of knowledge, we had all these different ways of calculating things, and so rather than throw a lot of them away, they kept them. If there's another explanation, I'd be interested to find out what it is, why we need 6 trig functions instead of just 3. But we have the 6, and so that's what we're going to focus on. Okay, so we've got these reciprocal identities. We've got these 2 identities for the tangent and cotangent. And then there's one last set of identities that I want to talk about. If we go back to this definition, if we take the unit circle here, so that this radius is 1, right? We can draw a radius out here as a hypotenuse, where that's 1. Drop the perpendicular there, so we have a right angle. Then this is x and this is y. And our angle theta is in there. And so the sine of theta is y, and the cosine of theta is equal to x. X over 1, and the sine is y over 1. And so this point is actually cosine theta, sine theta. Okay, now because this is a right triangle, it supports the Pythagorean theorem, or it will make the Pythagorean theorem true, right? Where x squared plus y squared equals 1 squared. And again, this is in the textbook as well. X squared plus y squared equals 1. Okay. Well, we know that x is the cosine and y is the sine. So if we replace them, if we replace x with the cosine and y with the sine, then you can see that the cosine squared plus the sine squared is equal to 1. Okay? That's what's called a Pythagorean identity. So, the way it's normally written is that the squared is written in between the sine and the angle. So it's typically written like this. Sine squared plus cosine squared equals 1. Now, one thing I want to mention here, something that's important, is that you could say, you know, sine squared alpha plus cosine squared alpha equals 1. True. Okay? Alpha is any angle, then this will always be true. If you say sine squared alpha plus cosine squared beta, that may or may not be true. Maybe it's true if alpha and beta are the same angle, but if they're different angles, then this will not be equal to 1. So it's important that these angles are the same angle when we're working with these identities. Okay? All right, so there's the first Pythagorean identity, sine squared plus cosine squared equals 1. And I'll give you this information. Your formula sheet will grow over the course of chapters 3 and 4. So you'll have this information just like you did for the midterm. I usually don't give this one because it's just a combination of this and this, right? So you'll have all of this information right here, as well as Pythagorean identity, and there's two other Pythagorean identities. See, what happens is if you take sine squared plus cosine squared equals 1, and we divide everything on both sides by sine squared, and I go through this in the textbook as well. This will be 1. Cosine squared over sine squared is cotangent squared. And over here, 1 over sine squared, cosecant squared. Okay, so 1 plus cotangent squared equals cosecant squared. And then, if we back up and divide by cosine squared, then we get tangent squared plus 1 equals 1 over cosine squared secant squared. So these Pythagorean identities come in 3 different versions. And again, you'll have this as well as this and this on your formula sheet. I encourage you to use that when you're taking the quizzes. Now, it's going to be tricky for me to make trigonometric identity quizzes. So I can tell you that if you look in the textbook, there's no answer key for sections 3.1 and 3.2 because there are a lot of different ways to get at the same answer. I've written up an answer key because in class we can just talk about the answers, but if we're not having class, it's kind of tricky. So what I did was I made an answer key that has one way to solve the problem. Now you may use a different method that is equally correct, and that's fine. But if people are stuck, I want them to have something to look at. Okay, so let's look at some problems here. Let's see, I'm gonna need to make some room for myself. Let's erase this stuff, and then I'll move that over here. So let's see here. Sine squared plus cosine squared is 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared is cosecant squared. Okay, so there's all of our identities for section 3.1. We'll introduce a couple more in section 3.2, and then we'll call it good. Now, I do want to tell you, there are a lot of trigonometric identities, okay? So I've kind of narrowed it down so that we're examining the most commonly used of these trigonometric identities, but there are a lot of different ones. And, you know, if you go into an area professionally that requires you to do a lot of trigonometry, then you can work with those identities in a similar way that you work with these. Okay? All right. So let's take a look at some examples, and I'll show you what I'm working with here. So first off, in problem 2, we've got tangent theta times cotangent theta plus tangent theta equal to secant squared. All right, now, before I get into this, I'll try to pick one that would be tempting to use some of these techniques that I'm going to ask you not to use, okay? So this is in the textbook on page 102. And so these identities involve changing one side into the other, okay? Now, you can work on this one for a little ways, and then work on this one for a little ways, and then show that they're the same. That's fine. But what I'm asking you not to do is don't add something to both sides. Don't divide on both sides. Don't cross multiply. Don't use the two sides interchangeably. We want to take one side and change it into the other, essentially. Okay? And we can do that in pieces where we change this into something and then change this into the same thing. Okay? But do that separately. And I will take points off when it comes time for the final exam if you fall into that trap that I'm asking you not to do. So there's a couple reasons why trigonometric identities are done this way. One of them is that we're trying to prove this equality, and when you cross multiply and add something to both sides, you're assuming that these two sides are already equal to each other. Whereas all of these problems really start out with a question mark above the equal sign. So that's one reason why we don't want to do that. The other reason why we don't want to do that is because in a lot of situations you don't have a second side. All you have is a trigonometric expression, and you're trying to change it into something that's easier to work with. Okay? That's another good reason why we don't want to interchange between the sides. I'll try to remind us of that as I'm going through these problems. Let's see here. Another thing that I think is helpful in the textbook on page 103, I've got this list of 4 strategies. So, number 1, write everything in terms of sines and cosines. I wouldn't do that for this one, okay? I'll talk more about that in a minute. Problem 2. Make a common denominator. And then add or subtract fractions. 3. Split a fraction. So I talk about that in the textbook, how if you have, let's say, a over x plus b over x, we've got a common denominator, so that's going to be a plus b over x. That's pretty straightforward, right? Splitting a fraction is just going in the opposite direction. It's where we have a plus b over x, and we say, well, then that should be equal to a over x plus b over x. Okay? You'll see a couple problems where this is really helpful. What's the last one? Factor and cancel. That can also be helpful. So these, I think, are 4 really helpful strategies for solving these trigonometric identities. This one right here, I would recommend just distributing that tangent into the parentheses. Okay? So, tangent times cotangent plus tangent squared. Is that really equal to secant squared? Well, we're almost done here, right? Because tangent squared, so here's an identity involving tangent squared and secant squared. The only thing that's missing is that we have tangent times cotangent, and this has 1. Well, cotangent is 1 over tangent. So you could just write a 1 here, and then we're done. You could go 1 extra step and say secant squared equals secant squared. In the answer key that I make, I take this extra step, and then at the end I write QED, which is a Latin phrase that mathematicians like to use, which means I'm done with the proof. This is what it's quo erat demonstratum, that which was to be proved. And so that's what it's saying, is that it's done. Okay? So this is fine. If you want to take an extra step here and put in the 1 over tangent for the cotangent, that's fine. You don't necessarily need to do that. Sometimes I get picky about skipping steps, but this is a step that's perfectly acceptable just to go straight from there to there, because these are going to cancel and you'll be left with the 1. Okay, so that's problem 2. That was a pretty straightforward problem. We actually didn't need any of these strategies. We could have rewritten everything in terms of sines and cosines. It would have been fine, but I think it would have complicated things. And the goal in a lot of these problems is to make things simpler rather than more complicated. All right, let's see here. Well, let's look at problem 4. We've got a cotangent theta, and then secant theta plus tangent theta equals cosecant theta plus 1. Okay. Well, let's do the same thing we did in problem 2, where I'm going to distribute the cotangent into the parentheses. Cotangent times the secant plus cotangent times the tangent, and that's supposed to be equal to cosecant plus 1. Well, we just saw in problem 2, this is going to be 1. Okay? I would, at this point, cotangent times secant, I would rewrite those in terms of sines and cosines. I think that's a place where that strategy would be helpful. Cotangent is cosine theta over sine theta, and the secant is 1 over cosine theta. All right, there's the cosecant. Secant, there it is, 1 over cosine theta, and the tangent, the cotangent, of course, is the reciprocal here, cosine over sine. So these cosines cancel out, and we're left with 1 over sine plus 1 equals cosecant theta plus 1. And that's just a definition. That's an identity itself, which is that the cosecant is 1 over the sine. And so we can take 1 extra step here and write the same thing on both sides, and we're done. Okay? All right, that's problem 4. Let's keep going with these. I'll probably end up doing half of these problems in section 3.1 in one video, and then I'll save the second half for a separate video, because it's kind of a lot to take in all at once. All right, let's see here. Problem 6. 1. Okay? Well, there's a variety of things that we could do here, and maybe I'll do a couple of them. The first thing I noticed is that you can factor a sine squared out of this, each of these expressions, right? So you can call this sine squared theta times cotangent squared theta plus 1, and we're supposed to show that that's equal to 1. Well, this cotangent squared theta plus 1 is the cosecant squared. And remember, the cosecant and the sine are reciprocals of each other. And so this is indeed equal to 1. And there we go. So there's one way to approach problem 6. You could also take this cotangent and rewrite it as cosine squared over sine squared. Then these sine squareds cancel out, and we get cosine squared plus sine squared equals 1. That's an identity we already know to be true. You can stop there. You can say 1 equals 1. Either way is fine. So you don't have to do both of those methods, right? Either one is sufficient for solving the problem. And that's what I was talking about in terms of an answer key. Those are both right, and so, you know, making an answer key is just difficult to do, okay? But I did it for this section, but I want you to understand each of those answers is really just one way of solving the problem. If you solved it a different way and haven't done anything against the rules, right? If you followed this and haven't done anything that is mathematically incorrect, then your answer is just as good as any one that I come up with. All right, let's see what else we've got here. Problem 8. We've got a cosine theta cotangent theta plus cosine theta over cotangent theta plus cotangent squared theta. And we're supposed to show that that's equal to the sine. So one thing I want to mention, and I'll try to bring this up whenever it crosses my mind, we know that sine squared plus cosine squared equals 1. If you see a problem, sometimes people see sine plus cosine, and they're like, oh, well, that's 1. No, it's not. No, this is not equal to 1. Okay? Maybe in certain situations it might be equal to 1, but in general it is not. Okay? It's the square of the sine and the square of the cosine that's equal to 1. And please don't try to tell me that you can square root both sides, because it doesn't work that way. All right. So what are we going to do here? Well, we could start out by writing everything in terms of sines and cosines. That's going to complicate a lot of things here, so I would hold off on that for a minute. You may need to do that, but you may not. We don't have any fractions to add or subtract. Splitting the fraction, the denominator is in 2 pieces, so splitting the fraction is most helpful when you've got a denominator that's just a single expression. Factor and cancel. That is, I think, what's going to work best here. Because look, you've got a common factor of cosine on the top. So this will be cosine theta times cotangent theta plus 1. And you've got a common factor of cotangent on the bottom. Cotangent theta times 1 plus cotangent theta. Those are the same. They cancel each other out. Great. So now we've got cosine theta over cotangent theta equals sine of theta. So, before I finish this problem, let me just say something about skipping steps, right? A minute ago, I pointed out something that I didn't mind if you skipped a step there. Here, if you just skip from this to sine equals sine, I will take a point off for that, okay? I want you to demonstrate that it actually is equal to that. Okay? If you've got you know, I think it was tangent times cotangent and replacing that by 1. That's fine. I can see where that's coming from. Here, just saying that this is equal to sine, it's not really enough, all right? You need to go through the process of demonstrating that this is equal to the sine of theta. So we're going to rewrite the cotangent as cosine theta over sine theta. And then multiply by the reciprocal, right? So that'll be cosine theta times sine theta over cosine theta. Those are going to cancel out, and there we go. Sine theta equals sine theta. And that's really the reason why I would take points off if you went straight from here to here, is because you're not just skipping one step, you're skipping 2 steps. Okay? All right, so that's problem 8. Let's see, I think I'm going to go through problem 16 in this video. So let's take a look at a couple more. We've got 4 more to look at. Problem 10. Sine theta plus cosine theta all squared. And then sine minus cosine theta all squared. And this is supposed to be equal to 2. All right. So, there's no shortcut that I can think of here. We need to square these out, okay? And again, please don't tell me that this is going to be sine squared plus cosine squared. It's not. You know, that's a mistake for algebra 1. Please don't make that mistake here. And then we'll have sine theta minus cosine theta times itself. And we want to show that that's equal to 2. So we'll get sine squared plus 1 sine cosine, and then we'll get a cosine squared and a second sine cosine. So this is going to be sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. So that's why I was saying a minute ago, this is not sine squared plus cosine squared. You've got this middle term, right? Same thing here. We're going to get sine squared minus 2 sine theta cosine theta, and then a positive cosine squared. So, once we do that, this all comes together very nicely. This and this cancel each other out. This is 1. This is 1. And 1 plus 1 equals 2. And there we go. Okay? All right. Problem 12. Problem 12, sine theta over cotangent theta, and we're supposed to show that this is equal to secant minus the cosine. Well, this one's kind of tricky. We could write this, so this is one where we might want to work on both sides at once. But if we're only going to work on one side, I would work on this one. Because this has 2 pieces, this thing only has a single piece, really, okay? And so I think it'll be easier to turn this into this than the other way around. But again, there are a lot of different ways to get a right answer in each of these, and if you find one that works for you, that's great, okay? Let's see. So I'm going to start over here. I'm going to do a combination of 1 and 2, right? I'm going to rewrite this secant as 1 over cosine. Now I need to make a common denominator so I can add these 2 fractions together so that we get a single expression for it, right? Because that's where we're headed towards. So we need a common denominator of cosine theta. And so this will be 1 over cosine minus cosine squared over cosine. And that's 1 minus cosine squared over cosine theta. Let's see here. I think I may, well, let's see what we get out of this. 1 minus cosine squared is sine squared, right? Now, these we know are true, and so we can restate these as, you know, sine squared equals 1 minus cosine squared. Over here, we could say tangent squared is secant squared minus 1. Okay? And that's because we know that these are already equal to each other. We've demonstrated the truth of them. All right? All right, so here, 1 minus cosine, so that's going to be sine squared theta over cosine theta. Now, we want to show that that's the same as sine theta over cotangent theta. Well, actually, let me take that, and let's rewrite the cotangent in terms of sines and cosines. That's cosine theta over sine theta. And then again, we're going to multiply by the reciprocal here, sine theta times sine theta over cosine theta. And there we go, sine squared theta over cosine theta. And there they are. So this is a situation where, notice I worked on the two sides separately. I did something on this side and then I turned this side into that. That's fine, okay? But what we don't want to do is to like add the cosine over on this side. That's something that we want to try to avoid, and I will mark your work wrong if you do that. Okay, so that's problem 12. We got 2 more to look at. Let's see what they have in store for us. Okay, let's see here. Oh, did I skip number 12? I can't remember how I labeled that one as 12 or 14. Well, let's go back and do number 12 then. That last one I did was problem 14. So let's go back and look at number 12. Cotangent plus tangent. And this is all supposed to be equal to the secant, which remember is 1 over cosine. Okay, so that's where we're headed towards. Let's go ahead. There are a couple things we can do here. We could try to add these together first, or we could multiply. We could distribute first. I'm going to distribute first, and you know, maybe I'll go back and see what happens if we try to add these together first. Theta times tangent. Let's see here. I guess I'm going to write the tangent and cotangent as sines and cosines, because that's kind of where we're at in this problem. So sine theta cosine over sine, and then sine theta times sine over cosine. And this is supposed to be 1 over cosine theta. Okay, so these cancel, and these get multiplied, and we get cosine theta plus sine squared over cosine theta. Okay, and now we're just going to do what we did in problem 14, which is to make a common denominator and add these fractions together. Okay, our common denominator is going to be the cosine. This will give us cosine squared plus the sine squared, and that's 1 over cosine theta. Yes, it is. 1 is cosine squared plus sine squared, and 1 over cosine theta equals 1 over cosine theta. So there's a good way to solve that problem. Let's back up and see what happens if we wrote these as sine over cosine to begin with. Would that make any difference? We've gone on long enough. I'm not going to take the time to do that. Let's do one more, and then we'll call it good on this assignment. Problem 16. What do we start with? Secant plus cosecant on top, and on the bottom, tangent plus cotangent. And that's supposed to be equal to sine theta plus cosine theta. Okay? Let's see here. Wow. Well, I guess since we've got sines and cosines over here, I would, I guess, rewrite all of this in terms of sines and cosines. That's going to be kind of a pain, but hopefully we can get where we're going. So the secant, right, is 1 over the cosine, and the cosecant is 1 over the sine. So that's on top. Here we've got sine over cosine, and then here we've got cosine over sine. All right. Well, it looks like we're going to need a common denominator of sine theta times cosine theta, both on the top and on the bottom. So there are some shortcut methods to doing this. If you're familiar with those and can do them correctly, that's wonderful. I'm going to go through the long way of doing this, which is to multiply this one by sine over sine, multiply this one by sine over sine, and then multiply both of these by cosine over cosine. Okay, so what we're going to end up with on top is sine theta plus cosine theta over the denominator. Sine theta times cosine theta. There's no canceling you can do in there. It's just going to stay like that. On the bottom, we're going to have sine squared plus cosine squared on the top, and then sine theta cosine theta on the bottom. And again, there's no canceling to do there. Okay, now we're headed for this. Okay, I'm going to use up this space to finish this off, but this is where we're headed. So what we're going to do is we're going to multiply by the reciprocal of the denominator. So we just take the numerator, and then we multiply by sine theta cosine theta over sine squared theta plus cosine squared theta. Those cancel. This is 1, and there it is. Sine theta plus cosine theta. And we're done. Okay, so like I said, I think that's enough to get us started with this section 3.1. I will try to make a good quiz to go along with this, but like I said, it's going to be difficult. I'm going to have some of the same issues I ran into with making those graphs, with the graphing quizzes. I'm going to do what I can to try to get at these concepts in those online quizzes, but when it comes time for the test, I'm going to ask you to be doing what I'm doing here on the board, even though we won't be able to do that online. Okay? So, we'll come back, I'll finish up this section 3.1, we'll look at section 3.2, and then we'll move on into the second half of chapter 3, which is a little bit different. As always, if you have any questions, please let me know. Thanks.